We now go to the solid phase extraction for liquid sample. So unlike liquid extraction, okay, it is incorporating one phase that is in solid form. Okay, that phase in solid form is usually particles that can absorb your analyte and leaving behind what's not needed, such as matrix. Okay, so in solid phase extraction, it is what we call as analyte is separated from rubbish. So imagine a filtration system in your water, drinking water. So it is the same. Okay. However, in water filtration system, the one that is not wanted, i.e. the rubbish, will be retained inside your sorbent cartridge, right? The one that you want is the one go out from the dispenser, the water dispenser. Okay. In SPE, it is the other way around. Okay. The one that you want, we retain on cartridge. Okay. Inside cartridge, and then you can do several washing to discard the matrix, and then you will get a very good concentrated analyte. Okay, let's go one by one from start. Yeah. So the principle of the SPE is retaining of the analyte on the sorbent bed. Okay, yang ni particle ni. Okay, while matrix interference, rubbish, okay, are eluted from the cartridge. Eluted means that we put elution solvent such as organic solvent to get the analyte out. Okay. Analyte subsequently eluted with stronger solvent because stronger solvent is usually needed by this analyte. Now we go to the steps of solid phase extraction. We have 4 steps starting from conditioning, sample addition, washing, and elution. As simple as that. But the hardest part is determining what kind of elution solvent, what kind of retention inside this. So that's the thing that a chemist must able to understand and explain to their subordinates or lab technician, for example. Okay, so first you condition the dry sorbent with solvent. What kind of solvent? Depending on your analyte and sample. And then you put the sample that is dirty. See, red denotes the analyte, interference are all of this. Okay, interference. The one that we want is the red one. Okay, you put everything here, and then you only want the red analyte to be retained here and eluted the last. So you put washing part, whereby, for example, the interference are only salt. Okay, so only washing with water will take out the salt out. Okay, while analyte will still be retained. The keyword is retained by the meaning of absorption. The principle is absorb. It absorbs onto the surface of the material. And then you put elution with stronger solvent so that you can get out the analytes out from this. So what happened to this cartridge? You can reuse. How many times you can reuse? It is usually depending on the efficiency of the cartridge. Maybe you can use from 5 to 10 times only. Okay, but if you don't want to reuse, it's okay. You just discard the cartridge because this is disposable, for example. But if you want to reuse, you can check the efficiency. Now let us watch a video on the step by step. You see that the color of the original solution from yellow turning into colorless, whereby this is the solvent that you use during elution. Okay, in before it is maybe up to 100 ml. Okay, now we have a very concentrated and it is colorless. Okay, so let us look one by one on the each procedure. During conditioning, okay, conditioning is usually using the same elution solvent that you use in the last step. Okay, usually you use the same elution solvent that you use in the last step. What is the function? This is for the material, okay, to be what we call as equilibrated. Okay, means that is to be ready. We are asking the material to be ready in terms of chemical interaction that is going to have with the analyte. Okay, and the common mass of sorbent used in cartridge SPE is around 50 milligram up to 100 milligram. So the requirement in cartridge SPE is that you have to have cartridge. As you watched it before in this video, it is usually it is like a 3 ml or 5 ml type of size of cartridge. Okay, then when it is equilibrated, you load your sample, your dirty sample, and you saw that in the video they adjust how many drops per minute. Okay, for example, if you use a very high flow rate, if you use a very when you put it and then zoom, everything goes in, the analyte or other interference doesn't have the time to interface or what we call as absorb here. Therefore, we have to give time. That's why usually you use several droplets per minute only. Okay, in order to fasten the droplets, to make it fast, you can adjust the flow rate to be higher. How do you want to use this? You can use what we call as vacuum pump. Okay, this vacuum pump will accelerate the droplet going in. And then after it's absorbed, okay, but you only want your analyte to be here. You don't want this. So you wash with different solvent used for elution. Okay, remember, if let's say you want to use elution with methanol, therefore during washing you have to use either water. It's all depending on your analytes. Okay, either water or any salt solution. Okay, during elution, you have to choose the good elution solvent. So what you can do is that you have to understand your analyte first. Okay, let's say your analyte is hydrophobic. Okay, hydrophobic, for example, protein. Okay, so you have to think of, okay, what my protein likes. Does this protein like methanol? Does it like acetonitrile, and so on? So you have to go into standard method, or you can go to published method. You see, okay, what have been used to elute protein out of SPE. So you choose that solution. Okay, choose a solvent, the mixture in which the analyte is highly soluble. Means that protein love acetonitrile, so you use acetonitrile. Protein doesn't love water, so if it doesn't love water, it will not come out. Okay, it cannot break the bond between the analyte and particles over here. And then I will go in the next video. I will explain to you how many types of solid phase material available. Okay, it is not universal. Why it is not universal? Because it cannot suit all analytes. We have millions of organic compound, right? So we have to adjust. Okay, if you want to analyze group A, you use cartridge with material A. If you have B, you use cartridge with B. So I will go into different type of the phase so that you can understand what to choose when you do your work later. And then usually in a routine monitoring lab, for example, Department of Chemistry Malaysia, or even in industry, they have hundreds of samples. If you have hundreds of samples, you want to use a helper. Okay, that's what we call as automated SPE. Okay, automated SPE. Okay, whereby we can put a lot of cartridge at one time, and then we just click, and then it will go into extraction. Most of research lab will have this manifold vacuum for 1, 2, 3, 4, 5 cartridge to be in. Okay, you can read here on what are the advantage, okay, between SPE and liquid extraction. The greatest difference between two of them is that in SPE it is using less solvent. Okay, this is if we are comparing between conventional liquid extraction and conventional solid phase extraction.